The Department of the Interior and Local Government, Central Luzon, presents this series of instructional videos as part of the formulation and updating of LGU Comprehensive Development Plans.
Developing the exposure database is the most crucial step in the CDRA process. Why? Because the maps and data that you will generate shall serve as the primary basis of your analysis. I'm sure you have heard of the saying, garbage in, garbage out. That's why you must ensure the quality of information that will form part of your exposure database. The outputs in this stage of the process are exposure maps for the elements at risk, namely population, urban use areas, natural resource-based production areas, critical point facilities, lifeline utilities, or infrastructure. Second is the attribute information on exposure, sensitivity, and adaptive capacity of various exposure units. Take note that for step 3, we will only discuss how to generate exposure maps and attribute information on exposure. Sensitivity and adaptive capacity will be covered in step 4. These are the activities that you need to accomplish. To simplify, you have to prepare the exposure maps and attribute information of all elements at risk in your study area. In a nutshell, the exposure database provides the baseline information pertaining to the elements at risk, location, sensitivity, and adaptive capacity attributes of the exposed elements. The process starts by generating exposure maps, ideally with the use of a mapping software, such as Geographic Information System, Quantum, or other similar programs. The exposure map should be based on updated and accurate map attributes and should clearly show the areas and structures that are exposed to a particular hazard. Other indicators that cannot be generated in the map can be supplied by primary sources, such as interviews and field surveys, or secondary sources, such as studies and census that were recently finished. Take note that we do not recommend a full-blown survey or study just for this purpose, since it will be very costly and time-consuming. As much as possible, use secondary data, conduct key interviews, and hold workshops with key people in order to fill in the data gaps. This is a simple illustration on how to generate an urban use exposure map. On the left side is the flood hazard map, and on the right side is the urban land use map reflecting the commercial, residential, industrial, and tourism areas. If possible, it's better to use an actual land use map to ensure that only existing built-up urban structures are included in the analysis. With the aid of a GIS software, you can overlay the flood hazard map on top of the urban land use map, resulting to a map that shows different types of urban structures that are highly, moderately, and marginally exposed to flood. There are 5 exposure units that you have to consider in building your exposure database. What should be included depends on your study area. For instance, many highly urbanized cities do not include natural resource-based production areas because they have no agriculture, forestry, and fishery areas. Let us look at each of them. Population exposure shows the spatial location and number of potentially affected persons in a study area. Among the indicators are residential area allocation per barangay, barangay population, and barangay population density. Here is an example of a map showing the population exposed to flood hazard. You will notice that the houses or residential areas that were categorized as low susceptibility were highlighted in yellow, while the orange ones represent those that are moderately susceptible. For population exposure, the ideal is to use an updated household map. If you have completed your community-based monitoring system or CBMS, you may use the household maps and the household profile there. If you don't have CBMS, you may ask your assessor's office if they can provide you a map of all residential units. Another way is to use the satellite image in Google Earth and form a team that can pinpoint all residential structures in the map. This method may take a lot of time, effort, and cost, so make sure to choose the best option that would fit your needs. Without a household map, the next best thing is to extract the residential land use map based on your land use map or zoning map. Make sure that the map is not simply in picture format such as JPEG or PNG, but that it is digitized in a GIS software. Otherwise, you won't get the information that you need. Using the GIS software, you can draw out important information such as in these yellow columns. Normally, the GIS will automatically produce this data in Excel file. On the other hand, the information in the orange columns can be obtained from the socioeconomic profile or PSA census. If you have CBMS, then much better. To obtain the population density in column E, divide the barangay population in column B to the barangay area in column D. Round off the answers into whole numbers because people or individuals cannot be in decimal point. Exposure percentage in column I can be computed in different ways. In the example shown, where the residential land use map was used, divide the affected residential area in column F to the total residential area in column D. But if you will use the CBMS household maps, divide the population affected per barangay to the total population per barangay. For the exposure score, use these parameters as your guide. If at least 20% of the population is exposed to a particular hazard, then the score is 4. Urban use area pertains to the built environment currently utilized for residential, commercial, tourism, sanitary waste management facilities, cemeteries, and other land uses unique to the locality. The indicators are urban use categories, area allocation per land use category per barangay, construction or replacement cost per square meter, and assessed value. This is an example of an urban use area exposed to liquefaction map. The liquefaction hazard map was overlaid to the existing land use map. In this case, you will get the affected urban uses in terms of its land area instead of the affected buildings and structures. This is still acceptable as per guidelines, but if you have an updated building and structures inventory map, that will give you a more accurate result. Using the sample map, you can generate the different categories of urban land uses, susceptibility level, total area per urban use, and affected urban use area per barangay. Then, you may consult the engineering office or building official for the data on building area and replacement cost. The affected value in column H is derived by first determining the building area affected in column E, then multiplying it to the estimated replacement cost in column F. In case you cannot identify the affected building area, you may make some estimates with the help of the zoning officer and building official. Please take note that you still have to assume the value of the affected structure even if it is classified under low susceptibility. The percentage exposure should be based on the building exposed. If you really have no data on area of affected building, just divide the specific urban use affected in column D by the total urban use in column C. Lastly, for the exposure score, use these parameters for residential and non-residential urban structures. Natural resource-based production areas pertain to areas that are utilized for crop, fisheries, and forest-related production. Among the indicators are classification, varieties produced, annual production output, replacement cost, and number of farming dependents. This is an example of a natural resource-based production areas exposed to flood map. Here, you can use an agricultural resource and industry map, which shows the type of crops and agricultural industries such as agroforestry, livestock, piggery, poultry, and fish ponds that are present in your study area. In the absence of such, you may extract the production forest, agriculture, agri-industrial areas, and related uses from your existing land use map. Make sure that you always validate the existing land use map since there could be already many actual changes to it. Columns A, B, C, and F can be generated from the exposure map, while other information can be supplied by key offices such as the Agriculture Office, Environment and Natural Resources Office, and Veterinary Office. The affected value is computed by multiplying column E, or the value of average output per hectare, to the affected production area. Meanwhile, the exposure percentage is obtained by dividing column F, or affected production area, to column C, or total production area. Lastly, here is the basis for the exposure score. Critical point facilities are facilities that provide key socioeconomic support services such as schools, hospitals, rural health units, local government buildings, air and seaports, communication towers, power-related facilities, and water-related facilities. This type of exposure map entails an updated map of all public and private facilities as mentioned a while ago. Without this map, you may also use the existing land use map and isolate all institutional land use and selected infrastructure land use. In this example, each type of critical point facilities or CPFs were mapped out per barangay. There are times that even the names of each CPF are included in the table. The map will automatically reveal the susceptibility and land area affected where the CPFs are located, while the number of stories can be supplied by the building official or key personnel such as barangay officials. The percentage of affected area is obtained by dividing the affected area of the CPF to the total area of the CPF, while the value of affected facility is computed by multiplying the building area affected and the replacement cost. The parameters of the exposure score are the same as the ones used for residential structures. The last exposure unit is the Lifeline Utilities, which includes the transportation, water distribution, drainage, and power distribution networks. Among the indicators are the classification, length or distance, and construction or replacement cost. For the Lifeline Utilities exposure map, you need an updated road network map, power distribution, and water distribution map. If you do not have a power and water distribution map, just focus on road networks since most of the power and water lines are also there. Remember to classify the roads according to hierarchy and include the road names and street names. As we have learned, most of the data can already be extracted from the exposure map. On the other hand, the replacement or construction cost can be provided by the engineering office or the DPWH office, while the affected value is computed by multiplying the affected road length to the replacement or construction cost. Take note that in this case, where the hazard is rain-induced landslide, only the roads near a steep slope were considered as exposed, while the rest of the roads, although categorized as low susceptibility, were determined as not exposed. But generally speaking, you may include the cost of affected structures or roads in the table even if they are identified as low susceptibility. Lastly, here are the parameters for the exposure score of Lifeline Utilities. At this point, your exposure data is already complete.